So, welcome to Oracle Engineered Systems. So, I'm happy to have you here to give you an overview about Oracle Engineered Systems and the benefit and the concept behind and what advantages for you as SAP customers will have if you're using this kind of new technology for your SAP system architectures. So, my name is Martin Roselieb. I'm working as SAP consultant in the Oracle Solution Center for SAP Competency, which is located in Walldorf. In all cases where a customer comes to us asking for a design of a new system landscape, a new system architecture for their SAP environment, we are starting from scratch. We are thinking about system size, we are thinking about uptime, we are thinking about disaster recovery, HA, whatever. We are starting with CPUs, we are going over I/O infrastructure, and basically we are reinventing the wheel every time. And so after a while, it now is time for a change here. It's time for an appliance. And that's what Oracle was doing by introducing the engineered system to provide an appliance to you, which gives you all the necessity, all the flexibility, which is required to run successfully SAP software on a hardware infrastructure. The whole idea is based on Oracle's Red Stack. What it's behind. Oracle Red Stack means that we take ownership, we as Oracle take ownership from the application part except SAP, so starting with the database, going over the operating system, down into every bit and piece of your system architecture. So down to the storage, whatever belongs to it, network, name them. With that, we offer you and we promise you that everything fits together very neatly and nicely, and that at the end, the result will give you more than the tiny bits and pieces you would have if you would do things on your own. So we have introduced 3 engineered systems, and I will introduce all 3 of you for you. So they are supposed to simplify your whole system landscape, especially for SAP. They are targeted at being agile enough, or very agile, so that you are flexible enough to grow within chassis, grow outside chassis, to have additional features like HA, so means high availability, disaster recovery, everything either pre-built within the cabinet or to be used pre-thought, pre-educated, pre-architectured in between systems. And with that, we want to achieve a simplification of your complete environment. Simplification means that whenever a customer comes to us with an issue, we start from scratch again, trying to find out what situation the customer is in, what kind of hardware do you have right now, where is the potential issue, and we are looking into it, and we are investigating from scratch what the situation is. With a pre-engineered system, it is not your system, it is our system. We are feeling at home when we touch your system. So we know exactly what components you are building, you have built your system on, what the dependencies are, which drivers, etc., etc. So for us, it's much easier to jump into your issue, and for you, it is much easier because you are advised in lectures how to operate it and how to run everything together. As I said, we have 3 engineered systems. So 3 different kind of architecture targeted for different purposes. Let's start in the beginning. We have the Exalogic system, which is supposed to be a farm of application servers together, if necessary, together with a single point of failure of an SAP installation like message enqueue server and so on. The second machine we are offering, the second engineered system, is the Exadata system. A very powerful database environment consisting out of several compute nodes working together, designed working together, so that consolidation of databases is the key here. And number 3 in the row on the right-hand side, and you are seeing it is spanning both the application server part as well as the database part. This is a machine which is based on Spark and not on Intel, targeted to cover the whole environment you might require. As I said, 3 different systems, but the basic concept of them all is just the same. So they all follow the same layout, guidelines, and targets, and that's what you're seeing here. So the benefits of and the business value you will achieve by using those systems are all the same. So of course you will lower the TCO. Of course we will provide you with extreme compute power necessary for your daily requirements. So all systems are supposed to be used as a data consolidation machine. That means we are not building system for one SAP system and one database. Instead, we are inviting you to put as many of your components, which you currently have distributed in your server landscape, into this grid computing, into this cloud of resources to find their home working nicely together. It is not just servers. It is not just a little bit infrastructure and glue code. It is the complete infrastructure, starting from the CPUs, going via memory, over the I/O channel, over network, etc., down to the storage. That means you do not have extra storage anymore. You have one appliance, a database appliance, for example, and everything you require is in there. And it's pre-installed. You don't need to touch anything except putting this rack or this collection of racks in your data center, connecting to power, connecting to network, and to configure the right IP addresses and passwords. That's it. It's meant to be an appliance, and it works as an appliance. None regarding how complex the machine might look from internally. From outside, it is simple, it is neat. Now let's look into the different machines. So number 1 is the Exadata machine. So up to 8 servers are included in here, and I name them compute nodes because those are the servers where your physical databases are then running on. Up to 8. Each of them consisting of 2 very powerful Intel CPUs. You can choose Linux or Solaris as your operating system. The big differentiator of Exadata compared to any other database system you can find is the storage cells. Here we have a layer in between, a compute layer in between the SJA and the storage. That means all I/O specific and compute heavy things do no longer happen on the database. Instead, they are using the storage cells and will be accelerated like crazy. A performance increase, and with performance here I mean quickness, response time increase of factor 5 for an OLTP system is easily to be achieved. A factor of 8 is to be seen for BI, for example. So this kind of acceleration you can only achieve and see with those combined systems, with these prepared systems, the engineered systems from Oracle. Because the storage engine you will never find and cannot buy outside those systems here. I said even the network is in between, is included. So if we are talking network, then we are talking InfiniBand. The quickest, the most low latency technology you can find right now. And the storage cells in combination with the InfiniBand network, those are the major accelerators for your environment so that the database can respond much, much quicker to the same request. So you do not need to do anything. You do not need to change anything. You do not need to optimize anything. Any bottleneck you currently might have will possibly still be there, but at a much, much higher level. So the achievable throughput, because of the quickness of the system, is drastically higher compared to any other. Of course, any other technology which is common right now, like flash caches and other devices, are included. So everything is pre-thought, pre-installed, pre-configured, and ready for operation as soon as it comes in your data center. And how to operate it? So we have the Oracle Enterprise Manager, the Ops Center, and via this you have the full control over the complete chassis, the complete cabinet, so you immediately see what the status is and what possible counteractions on incidents might be. System number 2, the one which is spanning not only the database but also the application server, is a similar concept, or the same concept as I promised, but a different technical architecture below. So instead of Intel CPUs and Intel servers, we have here a Spark architecture. We are using the Spark T4 server, a very compute power intensive type of architecture in combination with Solaris 11. Again, here we have the storage cells, which will accelerate the database via the factors I have already indicated with the Exadata system. So the benefit I have highlighted for Exadata is just the same coming down here for the supercluster. Again, the same concept, so the storage cells, the InfiniBand network. In addition to that, we have a ZFS storage appliance so that you can make usage out of additional storage for the application servers, for non-productive systems, as you like to. Again, the concept is the same. That means, again, here, the maintenance and the status control, etc., is done via the same tools. So again, Ops Center comes into place here. Then we have the Exalogic appliance, number 3 in my role of engineered systems. Here we target the application server. Up to 24 servers are here, consolidated in a single rack, a massive amount of compute power together with InfiniBand. No storage engine here, of course, because we don't have a database appliance here. But all other advantages from the other systems are collected here as well. You see here 3 different systems targeted at the same goal to be an appliance-like architecture where you just need to consider the required size and not the necessary technical details. When we are talking about a database appliance, then of course we are talking Oracle. We are talking Oracle RAC if you want to. Oracle RAC is an option you might want to activate just because of availability, but here even for scalability. So we have seen in lots of customer-related performance tests how impressively Oracle RAC is scaling here, so you feel nearly no difference between a standalone server and a collection of Oracle RAC nodes. This covers the single point of failures of the database. The SAP single point of failures will be handled in this presentation a little bit later. Of course, Oracle RAC is responsible for the RAC internal availability, the out-of-the-rack availability, so the synchronization to other racks, other locations is done via Oracle Data Guard. So via the very well-known read-log shipping, you ensure that a standby database, a disaster recovery database is ready for operation. Everything is pre-thought, not pre-configured here, but pre-thought, pre-designed, so you cannot get wrong by choosing those components. So I know lots of customers who are eager and considering to use Oracle RAC, but never dare to. Here is the chance to overcome this hurdle and go into means with this concept. As I said, up to 8 nodes are in an Exadata chassis, up to 4 nodes in a supercluster. So you can start small by using 2 nodes only, 2 half nodes even if you want to. So and you can grow within the chassis. As soon as the chassis is full, you can extend this concept by adding more chassis as you like to. For the SAP single point of failures, a different concept is required. Of course, Oracle RAC can help the database being available, but for the SAP, we need something different. And so we have decided to include the single point of failures into the Exadata system if you want to. So we take care about, like a cluster, it's just that Oracle pre-thought and predefined everything. If you do not want to have the idea, or if you do not like to have the idea to run SAP software on Exadata, you are free to relocate this into the front end, into the Exalogic system, and to run that there in a standard cluster as you would like to. With supercluster, since you have application servers and database, both options are available as well. So we cater for SAP single point of failures, we cater for database point of failures, and of course, the complete stack, the complete rack is fault tolerant, means having no single point of failure nowhere. Here is a nice example in regards of how customers often want to have their high availability and disaster recovery scenario designed. So we have two Exadatas in this example here on both sides connected to a collection of application servers. The production side is maybe on the left-hand side, the non-productive system on the right-hand side, and the interconnection and the synchronization between the systems is taking place via data guard. It's obvious that you can revert the order, you can move the production to the right-hand side whenever you like to or whenever it's required, and the same for the non-productive systems. As I said, we are taking care about your system not only on the highest level, so all our systems are protected down to the last disk, to the last item, and here is a list of features which are storage related and describe just how much effort and how many creativity we put into our systems. We are thinking it through from start down to the end. Having said all that, coming as an appliance, it is easy, it is simple. One thing to mention, so if you build things on your own, it looks straightforward in the beginning, but running such a system is always a hassle because you need to patch, you need to upgrade, you need to ensure that dependencies are met, and so on. So it starts at the disk and it ends at the SAP version. So we cannot consider the SAP version, but we can at least consider the database version. So when you are running Exadata system, for example, or a supercluster system, then the patching is very easy because it is just a single file which you transfer. And it's not a file which Oracle provides, it's a file you receive from SAP. That means with the so-named SAP bundle patches, the whole patching, the whole upgrading of different components is just a single step which needs to be repeated server by server, I have to admit. But at least you do not need to consider the storage layer, the InfiniBand layer, the disk layer, the database layer, etc. Everything comes pre-tested, pre-engineered, and it's a very, very simple collection of commands to make it happen. So that means your complete maintenance of your systems are done in a very, very different way. Very simple, as pre-thought as the systems are, the complete life cycle is. And of course, it is very simple for us to help you if something happens. I said it in the beginning, we are feeling then home in your systems, and I think that is a real big advantage for both of you. For you having an issue, and for us in the role of helping you. So let me wrap up. So engineered systems are target for consolidation of resources, especially for SAP customers. I do see lots of benefits. All these starting from scratch and reinventing the wheel is now history, because we know how your target system technically looks like. We have no idea about the size and the components and the memory requirements, etc. But we know at least that your necessity can be and will be covered nicely with this kind of concept. Imagine how much time and stress you are saving if you follow our advice, our recommendation here. So Oracle Engineered Systems is, from my perspective, the future target, the future architecture of your SAP environment. Thank you very much for your attention. and any questions will be answered over there in the booth. Thank you.